So now we're going to talk about basic operations with matrices. And these are fairly straightforward, but still the examples will be helpful. In matrix addition, first of all, the two matrices have to be the same size. Otherwise, the sum's undefined. But if the matrices are the same size, then you add them by adding corresponding entries in the same positions. For matrix subtraction, well, you add the opposite, like usual. Scalar multiplication, just like with vectors, to multiply a matrix by a scalar, or a real number, you multiply each entry of the matrix by the scalar, like with vectors. So for example, if we have these three matrices, which are all 2 by 3, 2 rows and 3 columns, so right off the bat, we could, for example, just add all of these, and that sum would be defined. Now notice here, B is interesting. B is the 2 by 3 zero matrix consisting of all zeros. And it's the additive identity in the sense that if you add this matrix to any other 2 by 3 matrix, you get that other matrix. However, even though it's the additive identity, it's not what we call an identity matrix. That's a multiplicative identity. We'll talk about those later. They look different. Okay, let's do it. Let's find some let's find some matrices. Here's a matrix expression: A plus B plus 2C. First off, in case you forgot, how dare you? Let's replace A, B, and C by what they were, right? In numerical form, right? In the brackets. A was this matrix. B was the zero matrix here. C is this matrix. Over here, well, if you perform matrix addition, just like we said before, this is the additive identity for all 2 by 3 matrices. So when you add these first two matrices, you get the first matrix. Over here, when you take twice a matrix, you multiply each of the entries by the 2. You double each entry. So you get 2, 4, 0, 0, 2, negative 6. When you add these matrices, add the entries in corresponding positions. 2 plus 2 is 4. 0 plus 4 is 4. 1 plus 0 is 1. Negative 1 plus 0 is negative 1. 3 plus 2 is 5. And 2 plus negative 6 is negative 4. There you go. Now, this is not so vulnerable to avalanche effects in the sense that if you make a small error somewhere, it may haunt you in that entry, but not so much in the whole matrix. Whereas before with things like Gebs, if you made a mistake early on, it could really hurt you in all sorts of ways down the line. Find A minus 5C. The key point I want to make here is that if you're basically subtracting a matrix or subtracting basically if you're subtracting a matrix and there's a number here, right? Okay, you might want to think of matrix subtraction as adding the opposite. So instead of A minus 5C, we can think of this as A plus negative 5 times C. So over here, here's the matrix C. We can start by multiplying by negative 5. In a way, it's kind of a distribution. You multiply each of these entries by the negative 5. You get these. And again, to add matrices, you add corresponding entries in corresponding positions. 2 plus negative 5 is negative 3. 0 plus negative 10 is negative 10. 1 plus 0 is 1. Negative 1 plus 0 is negative 1. 3 plus negative 5 is negative 2. 2 plus 15 is 17. Again, there you go. And if you make a mechanical error, I'll tend to be fairly lenient. But don't make too many of them, though. Next, we're going to talk about how to multiply vectors and matrices. And it's not quite as easy as you might think, but we are going to see some familiar operations next time.